Hi everybody, we're going to start day 2 of our notes on polynomials. So today we're going to be dealing with multiplying polynomials, and there are a couple different ways you can handle it. Basically, when we're multiplying polynomials, there's so many different combinations that can happen. Like you could do a binomial, which is 2 terms, times a monomial, which is 1 term. You could do a trinomial, 3 terms, times a binomial, 2 terms. So there's lots of different things, and there are some methods that are great for a certain kind of situation, and there are others that work for everything. So I'm just going to show you all the methods, and you can kind of decide which one works for you, and which one will work for you with certain situations. Okay, so let's go ahead and give this a try. So one of the first things with multiplying, okay, basically we're just doing distributive property when we multiply. So the first method is straight up distribution. Like just do the distributive property to get it going. So here's an example. We have this monomial, 3x cubed, times this trinomial, negative 2x squared plus 5x minus 7. And we're going to multiply these just by distributing this term, which is very large, I know, to each of these terms. So we're going to multiply this 3x cubed times the negative 2x cubed. So this is where you need to know exponent laws because you're multiplying, so that means you're going to add the exponents. Okay, you're going to multiply it by the 5x and by the negative 7. Remember, that's a negative 7 there. Okay, so when you're multiplying, remember, numbers on the front get multiplied together, exponents get added together. So 3 times negative 2 gives you negative 6, 3 plus 2 gives you 5, so that becomes negative 6x to the 5th. Do it for the next one. So 3 times 5 gives you 15, but 3 to the third times x to the first, remember that's an invisible 1 there, so you add 3 plus 1 gives you x to the 4th, so you get positive 15x to the 4th. And then 3x cubed times negative 7, you're just going to do the 3 times negative 7 and keep the variable and exponent the same, so you get negative 21x cubed. Okay, now that you've multiplied, the last thing you need to do is make sure that there are no like terms you need to combine, because if there are, you need to combine them. And you want to make sure it's in standard form, so in order by the degrees of each term. So this one has an exponent of 5, 4, and 3, so there are no like terms going on because they all have different exponents. And it just so happens they're also in order because the degree of this guy is 5, 4, and 3, so it's in order from greatest to least. So that means I can just put it all together. So I have negative 6x to the 5th plus 15x to the 4th minus 21x to the 3rd. And that's my final answer. Just multiplying it together. Okay. So here's another example. This is 2 binomials. Multiplying 2 binomials has the most options for you because you could do the distributive property like I just showed you. But then there's 2 other methods you can do for it. And one of them is exclusively for multiplying binomials. Okay, so I'm going to show you all the possibilities you could do with this. So distributive I can't talk anymore, guys. Distributive property still works. So, but instead of just having one number out here, you have an entire binomial. So you're actually going to distribute that whole binomial to each term. So you're going to multiply x plus 3 times the x and x plus 3 times the negative 6. Okay, it looks weird because you're like, oh, I can't do that, but really all it is you're setting it up like this. So x times that whole parenthesis and negative 6 times that whole parenthesis. Then what you're going to do is distribute like a smaller portion, so it's easier then. So you're going to distribute the x to the x and to the 3. You're going to distribute the negative 6 to the x and to the 3. Okay, so it's just doing 2 kind of lumps, rainbows, whatever. You're doing 2 distributive properties basically. So now I just go ahead and multiply it. X times x gives me x squared. X times 3 gives me 3x. Negative 6 times x gives me negative 6x. And negative 6 times 3 gives me negative 18. Okay, so these are the results I get when I do distributive property. Now I have like terms here. I have a 3x and a negative 6x. So those I need to combine. Okay. So 3x plus negative 6x gives me positive 3x, so that's what I have now. I just want to make sure that I have no other like terms to combine, which I don't because none of them have the same exponent and variable. And then I want to double check to make sure it's in order. So this has a degree of 2, 1, and 0, so that is my final answer. Okay? So even if that was a trinomial in front, or this was a trinomial in the back, you could still do this. You just take the whole binomial, polynomial, whatever it is in the front, and you multiply it by each term in the second one, and then do the distributive property again. Okay? Now, another method you could use, which does the same thing as distributive property. You're basically using distributive property in every one of these methods. It's just a different way of organizing your thoughts. So instead of having all those arrows, a lot of people like to use, I don't know how much of this is going to pop up. Cool, none of it. Love it. Is using a Punnett square. Okay? This is something I love to use because it's very well organized with like your thought process and everything. It's also very similar to a method where people use algebra tiles. That's basically a concrete, like they're shapes that you use to kind of figure out like what does it create, and then you can add them together and stuff like that. So I'll show you how to use algebra tiles in class when we do like for a warm-up or something. It's not that bad, but you will see it on your test and on the SOL. So I just want to make sure you know what it looks like. Basically what it is you set up a box. So I set up a box 2 by 2 because I have a binomial which has 2 terms times another binomial which also has 2 terms. So each side, you should have enough boxes for each term. So on the top I'm going to put the x from the first binomial and the 3 from that binomial over each box. And then on the side here, I'm going to put the x and the -6 from the second binomial. So that way each term is on a box. Okay? And then I fill in these boxes by just multiplying these terms together. So x times x gives me x squared. X times 3 gives me 3x. X times -6 gives me -6x. And 3 times -6 gives me -18. I like it a lot better than the distributive property because sometimes with distributive property, you guys draw the arrows, but might forget to do that last multiplication for the last term. With the box, you know you're not done until all the boxes are filled in. So that's why I like this a little bit better. And you can use this box method with any kind of multiplication. If it's a monomial times a trinomial, you just make a 1 by 3 box. If it's a trinomial times a trinomial, it's a 3 by 3 box. Like, the boxes work for any kind of situation. So then I just go ahead and take whatever inside the box and I write it out. Oop, you can't see some of it. Let's do that. So 2x, or sorry, not 2x, x squared goes in the front, 3x, then -6x, and -18. So I just write it out, and then I combine my like terms again. 3x and -6x create -3x, and that's my answer. Okay, just like the first one with distributive property, I just find it's a lot less arrows and a lot more organized, so the chances of me forgetting to do something are a lot smaller. That's why I like the Punnett square. Oh, and I keep calling it the Punnett square because my students have always said, oh, it looks like the Punnett square we do when we do genetics or something like that. Whatever. It's the box method. I call it Punnett square, but whatever. It does the same thing. Okay, and the last one is FOIL. Okay, FOIL is an acronym that allows you to memorize like what needs to be multiplied together to do your multiplication. Now, warning though, FOIL can only be like done when you're multiplying 2 binomials. It cannot be used with any trinomials or monomials or anything else. It can only be done when you have 2 binomials. Okay? So it's a quick way to do binomial multiplication, but it's not a great way to, this should not be your only method that you memorize. Okay? The box method or distributive property, that one you can use no matter what the situation is with multiplication. But FOIL should be you should have a backup plan no matter what. So we're still doing the same thing, 2 binomials, so we can actually use FOIL for this. Basically, they each stand for what you're multiplying together. So F stands for first, so you multiply the first terms of each binomial together. So you're going to do, and on your paper you should write for F, x times x equals x squared. Okay? And then O stands for the outer terms, so the one in the front and the one in the back get multiplied together. So x times -6 for O gives you -6x. And then I stands for inner terms, so the ones inside the whole thing, so 3 and x. You multiply that together, you get 3x. And then L stands for the last terms of each binomial. So 3 times negative 6 gives you negative 18. Okay? Again, you're going to want to combine like terms of negative 6 and 3x. And that still gives us negative 3x, so you still get the same thing no matter which method you use. Okay? All possibilities going on there. Just be careful because FOIL does not always work. You can only use it for multiplying binomials together. Okay? So please, please, please be aware of that. You guys have to try on your own, so you're going to try them. They're both like multiplying binomials together, so you can use any of these methods. If you were going to use FOIL, that's fine. You do that for one, but practice another method as well, so that you are comfortable with both methods. Okay? If you don't want to use FOIL at all, that's totally fine. You can try distributed property and the box method, but nobody should be using FOIL for both. I want you to practice a different method. Okay? So give that a try. It should be, you should be good to go. And if you have any questions, please let me know, and we will go over this in class and do a ton of practice on it. Okay? All right. I'll see you guys later. I keep saying that, but I don't know where my thingy is. All right. Bye, guys.